Hey, this is Kevin Shryock coming to you with the physics question that you submitted. So you asked about a force for 40 newtons. So a force of 40 newtons accelerates a 5.00 kilogram block at 6.0 meters per second squared along a horizontal surface. The coefficient of friction is, and then it asks us for it. What are we going to start with? Well, you know that my favorite thing is always to start with a picture. So I'm going to start with a picture. And so what are we working with here? It says that we've got a block, so I could draw a block. There's my block, a curvy block. So I've got a curvy block, and I've got a force that's acting on it, and it is accelerating. It doesn't say anything about an angle, so I'm just going to say that it's a force here, force acting on it. It does say that there is friction, so I know that I've got some friction happening. I'll write that as the force of friction. Alright, what else do I have? I have an acceleration. What's the acceleration? Well, friction never creates its own acceleration. It's just going to impede that or interrupt that or get in the way of what we're trying to do. So we could say, okay, the acceleration is going to go that way, because that's the way that we are pushing it. And what else do I have? That's about it. It says it's a horizontal surface, so I can draw a horizontal surface, and that's just about all I've got. So that's my picture. What other kinds of pictures? Well, I'm seeing a lot of forces in my picture, and another way to draw a picture with forces is to do a free body diagram. So if we are going to do right over here to the side, the free body diagram for this situation, what's happening to this point object? Well, I've got the force, right, that I am applying. I've got the friction. The friction is what is getting in my way. Oh, let's make the pen work there. Force, friction. What else do I have? Well, it doesn't show it in this picture, but it does say that it's on a surface, and if two surfaces are ever in contact, two objects are in contact, that means I've got a normal force. I've got a resistance that's keeping this block from falling through the table. So let's call that my normal force. I'm going to use N. You could use force normal. I'm just going to use N. And then it's a block. The block has some weight. It's got some mass, so that means that the block is going to be pulling down. So that means I've got weight. All right, great. What else am I working with here? I've got, well, I'm kind of looking ahead with the things I know from class, and that's saying that I'm going to use mass and force friction, and I've got x's and y's, and I need to create an equation. Well, a great equation to always start with whenever you're working on forces is to work with the sum of forces equation, which is Newton's second law. So Newton's second law is the official title given to the fact that the sum of the forces is equal to the mass times the acceleration net. Now I want to take a moment here and pause and really stress that when you're doing problems like this is the acceleration net. This is going to be equal to the force net. Net just means the resultant. The resultant means the result of all of these forces. This is not something that you can break each individual force into and say I'm going to substitute in the acceleration it gives me for the force due to weight or the force due to friction. This is the overall total resultant result of the forces. So what do I have? Well, I could either deal with this sum of forces, and this talks about all directions. All directions are difficult to add together, and the y really doesn't affect the x, right? Moving up does not mean that I have to move sideways. So this gives us permission to break this down into its components, and I can write that the sum of the forces in the x is equal to the mass times the acceleration in the x. This would be the net acceleration in the x, but I'm just going to write it as acceleration of the x to keep my work a little nicer. And then I could break this over here, right? The sum of the forces in the y equals the mass times the acceleration in the y. And this is my breakdown. Breakdown there, and my breakdown there. Alright, let's keep going. Let's see what we can do. Let's start maybe with the forces. Well, we'll start with the x. Why not? What is in the x? Well, I've got a force that I am applying, which is moving to the left. That gives it a negative sign. So I've got my minus my force, and I've got a positive force of friction. And that's going to result in my mass acceleration x. Do I know all of these? Well, the force I'm applying I know is going to be 40 newtons, so I could say minus 40. The force of friction I don't know, but I know that I could solve for it using the equation mu Fn. In my example I just used n, so I'm going to keep using n. and that's going to be equal to the mass times the acceleration in the x. Oh wait, I know the acceleration, so let's go ahead and erase this. And I know the mass as well. Let's write both of those in. Why not? The mass is going to be 5 kilograms. No need to convert anything there because that's my standard scientific unit. And then my acceleration is my 6 meters per second squared. That's also in the proper units. Great. What have I got? I've got the mu, I don't know mu, and I've got n, I don't know n. Oh golly. Well, that means I can't solve this equation anymore. I can maybe simplify it a little bit. I could write 40 plus mu n equals 30. And then I could say mu n equals 30 plus 40 would be 70. But that's about as far as I can go. So I have to go searching for variables elsewhere. Thankfully, I've already written this other equation, this y side of it, so let's do the y side of it and see what we get. Well, I know that going up in my y direction, I have the normal force, and I know that going down in my y direction, I have the force of weight, and that's equal to the mass times the acceleration in the y. Now, as I keep this going, I'm noticing acceleration in the y. The problem didn't give me any details to say that this box was levitating off of the ground or was sinking into the table, and it didn't say that it started in any direction. I'm not thinking there's an acceleration in the y at all. This is not going to be changing its speed. It's going to be moving only sideways. So I can really just move this whole thing to 0. I could say the acceleration is 0. Mass times 0 is going to be 0. So I could say that the normal force minus the weight is just 0, which means that the normal force must be equal to the weight. And the weight I can calculate using mg, which we know is going to be 5 times the gravitational constant. The gravitational constant is 9.8 meters per second squared. That should be second nature after you get through your kinematics chapter. So kinematics chapter is going to drill that into your head. 9.8 meters per second squared is gravity all the time when you're on the surface of the Earth or pretty much near it. Okay, so what do I have? I have n. N is equal to just a little less than 40, it looks like. What's that going to come out to? Oh, I didn't simplify it all but in my calculator. Let's take a quick sec, type it in. 5 times 9.8. It should give me about 39. 49. There we go. 49. 49. And this would be newtons. But I'm not going to write my units because I already have an n over here and it's not what I'm asking for. I don't want to confuse myself. So, what can I do though? I have the normal force is equal to 49, and I have an equation over here with my mu in it. My mu is my coefficient of friction. Let's plug this in. I could say mu times my 49 Newton normal force is equal to 70. And if I do some quick math there, I say 70 divided by 49 is going to be a coefficient of friction of 1.43, and that is unitless. It's just a coefficient, but that is my final answer. Let's go up and make sure that it's there. 1.43 is going to get me, ooh, I don't see 1.43. Let's go back and check through the math. So 1.43 gets me pretty close to 1.6. Maybe I did some rounding errors here. Let's do 40 minus 5 times 6 divided by 49. Oh, I got 0.2 this time. Where did I mess that up? Ah, that's where it is, right there. Oh, so we got to learn a little bit about when Kevin messes up a problem. What does he do? Well, he went back and checked, and where did I mess up? I messed up right here. I thought that the acceleration was a 6, and it's not a 6. My acceleration points to the left. That's going to be a negative 6. So that's actually a negative 6 right there. So let's flow that through and see how it changes our math. Well, this instead of being positive 30 plus 40 is a negative 30 plus 40. So let's erase this. This is going to become a 10. Which means that this is going to become a 10. Just turn the 7 into a 1 right there. There we go. That becomes a 10. And then 10 divided by 49 gets us about 0.204. Alright, I like that better. A coefficient of friction that's above 1 is something to maybe think about. There's a couple of them that are above 1, but not many. And they're definitely not much above 1. So 0.20, and that's our unitless coefficient. Let's go up and check for that. 0.20, there we go. It's right there on letter E. So there you go. Even the tutor can make some mistakes, but it's not a big deal. You just go back and double check your math. Leave a little time at the end of the test to double check it, and maybe next time I do my resulting forces, maybe I'll choose to set it to the right, and that might keep me from tripping up. Either way, we got there. There you go. Thanks so much. Hope you enjoy. Let me zoom out so you can get a final picture.